Hi, this is Chapter 3-8. We're going to investigate slopes of parallel and perpendicular lines. So, this is our notation. Two lines straight up and down would indicate that lines are parallel. This upside down T would be indicating that lines are perpendicular. We're going to need the slope formula from before, and we're going to need to know the slope-intercept form of an equation where m is the slope and b is the y-intercept. Alright, parallel lines. In this image, these two lines are parallel, and they have negative slopes. They are going down from left to right. But we need to verify that these slopes are identical. So if we look at this, we're going down 1, 2, 3 spaces between C and D, and we're going across here down 3 spaces, and we're going across 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, which this simplifies to negative 1/3. And the question is, with line CD, does line AB have the same slope? Well, we are going down 1, 2, 3, and over 1, 2, 3, 4, 5, 6, 7, 8, 9. Clearly the same. Let's double check. 1 and over 3, down 1 over 3, down 1 over 3. They are clearly both a slope of negative 1/3. Since the slopes are the same, then those lines have to be parallel. And because the slopes are negative, it's going down from left to right, negative slopes. Okay, zero slopes. This line, the equation is going to be y equals 0 slope x plus the y-intercept is 8. Now if you want to simplify that and say that y equals 8, so be it. This one down here, y is equal to 0x plus 4, or y is equal to 4. But notice that in both of these cases, we are talking about both slopes are 0. So we have a slope of 0. Since both are the same measurement of slope, the two lines have to be parallel. Okay, these are positive slopes. Let's see if the slopes are equivalent. Let's see, are the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 going across, and you're going up from negative 1 to 5. So you're going up 6 and over 12. So that's going to be a slope of 1/2. Does that make sense with this line over here? Over 2, up 1, over 2, up 1, over 2, up 1. Yeah, these both have equal slopes. Therefore, we conclude that those lines are parallel. And it's a positive slope. Okay, undefined slopes. In both cases, you're dividing by 0. You're going up a whole bunch of spaces, and you're not going left or right at all. So these are undefined slopes, and they're both vertical lines. So this line is going to be x is equal to 4, and this line here is going to be x is equal to negative 6. But they are clearly parallel. The slopes are equal. They're both undefined. Let's not get excited about the equivalency there. But since both slopes are undefined, straight up and down, then the lines are parallel. Okay, if you're given an equation and then you want to have another line be parallel to that equation and pass through that point, well, you need to identify the slope of the original equation. So the original equation, first step, find the slope. Find the slope. So that's going to be, and that basically means solve for y. So you have 2x plus 3y is equal to 12. Subtract 2x from each side, so you get 3y is equal to negative 2x plus 12. Let me make that minus sign a little more obvious. Divide everything by 3 to solve for y. Y is equal to negative 2 over 3x plus 3 divided into 12 is 4. This is the slope. That's the critical information that you need to know. The coefficient, the number in front of the x, that is the slope. Where did I get that from? Let's try to squeeze that into here somewhere. Y equals mx plus b. That number in front of the x is the slope. Well, now that you found out that this is the slope right there, now we can do the math. This is the x, this is the, oh sorry, they're asking later on whether or not that's the point on the thing. Okay, let's see, let's keep going. X and y. We're going to then take that information and put that all into y equals mx plus b and get going. Okay, here, let me just try to make some space. Let's remember that the slope is negative 2/3. Okay, and I'm going to erase all this stuff, so this can get out of our face here. And we can go to the second part. Okay, so part 2. You copy down y equals mx plus b, and you put the appropriate information in the right place. Look, x is 3, y is negative 7, and our slope is negative 2/3. And then copy down the equal sign, copy down the plus b. Well, negative 2 times 3 is going to be negative 6. Negative 6 divided by 3 is going to be negative 2. Add the 2 to both sides, you get negative 5 is equal to b. And now we're asked what is the equation, so then you take this structure y equals mx plus b and substitute in a letter y for y, put the value for m, same slope because it's parallel, minus 2/3, put an x for x, and now the b is negative 5. That's your equation. Now, I made a follow-up question and asked if this point is on the line. Well, it's always 0 and then a b. Well, if that's the b, that's a negative 5, that's the b. This point is clearly on the line. Let's go to the next page and double check this. See, I wrote the two equations already. This was the original equation in black. That was in standard form. Solving for y to find the slope. That was your, y equals mx plus b. Look, there's your b, 0, 4 for the coordinates. And negative 2/3 is the slope. Got it. And then on the previous page, we came up with y equals negative 2/3 x minus 5. Bam, that's what we got over here. And I put it in standard form just for fun. But you'll notice here, does this equation match? Look, there's your minus 5, down 2 over 3. Yeah, that clearly matches. Same slopes. Yes, the lines are parallel. Looks good to me. Okay, now we're going to talk about perpendicular lines. The big thing that you have to know about perpendicular lines is, first off, we have this notation. There's your perpendicular symbol. Whatever the slope is for one line, if you take that fraction of the slope, flip it, and change the sign, the negative reciprocal of that slope will create the slope for the other line. So look, this slope looks to me like we're going over 2 and up 1. So this is a slope of 1/2. So if you flip it, take the 1/2, let me put this in the right notation, right color. 1/2, if you flip that, you're going to get 2 over 1 and change the sign, minus 2. Is this red line negative 2 for slope? Down 2 over 1, down 2 over 1, clearly is. This line is perpendicular to that line. Okay. Let's see, I wrote the equations for it. Oh, we have a simple test to see if these lines are perpendicular. Take the first slope, which was 1/2. Multiply it by the other slope that we created, the other line, which was negative 2. When you multiply those, do you get negative 1? If you do, then yes, the lines are perpendicular. Whoops. Okay, and they are. Okay, let's keep going. So let's see, are these two lines perpendicular? Well, let's see, we're going down 1, 2, 3, 4, 5, 6 spaces and over 1, 2, 3, 4. Sounds like This slope here, you're going down 3 and over 2. So that's negative 3 over 2 is that slope. And this one you're going over 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4. So this one you're going over 3 and up 2, over 3 and up 2. So this slope is going to be 2 over 3. Are they negative reciprocals of each other? Yes. So the lines are perpendicular. We can double check, take the two slopes and multiply them against each other, and do you get negative 1? Yeah, you get negative 6 over 6. I'd call that a negative 1. Yes. Here, I'll put a big yes. Okay. Okay, let's see. We've got a line with a slope of 0, and we need to create perpendicular lines. This line that has a slope that's undefined, if you notice, no matter where I place it, it is perpendicular to the horizontal line. So in this case, where I left it, this is x is equal to positive 3. Y is equal to 8. These are perpendicular lines. Okay? Alright, what's the equation that's perpendicular to this line but contains that point? Well, the first thing you have to do is solve for y. So you get 2x plus 3y is equal to 12. Subtract the 2x from each side. Divide by 3. So you get y is equal to negative 2/3 x plus 4. There's your slope, but it says that it has to be perpendicular. So if it's perpendicular, you have to take this value and flip it and change the signs. So this slope is going to turn into, flip it. It was negative, it's now going to be positive. This is going to be the slope of the perpendicular line. Okay. See if I can copy that and drag that up. Yes. Ugh. Oh well, hold on a second. Man, technology's cool. I could erase all that and save you time. So okay, this is going to be our new slope, and then you want to contain that point. So you're going to write y equals mx plus b. This is your x, this is your y, and this is going to be your new m. So then you substitute that into here. So this is negative 5 for the y, 3 over 2 for the slope, 7 for the x. Oh, this is going to be a fraction. So this is going to be 21 over 2 plus b. This is going to be negative 10 over 2. I made a common denominator. Negative 10 divided by 2 is negative 5. Then you're going to subtract the 21 over 2 from each side, which is going to give you negative 31 over 2 is equal to b. And now you have your b, you have your new m, so you write y equals mx plus b. Y is equal to the new m, 3 over 2x, and then there's your b, minus 31 over 2. Let's verify that in the next page. Yep, that works. There's your original equation. And then there's the equation we found on the previous side. And see, look, that's perpendicular, all right. Does it contain the point 7 minus 5? 7 comma minus 5. Let's see, 7 down 5, sure does. Yeah, I'd call that a win. Okay. Now let's see. We're given a point, given a line, y equals 2/3 x plus 1, and a point 4 and 8. So, perpendicular, you take that, the 2/3, flip it, 3 over 2, change the sign. So it's negative 3 over 2 is our new m. This is your x, this is your y. So your x is 4, your y is 8 plus b. Y equals mx plus b. That's where I'm getting all this from. So let's see. 2 into 4 is 2 times the negative 3. You get negative 6 plus the b, and 8's over here. Add the 6 to both sides. 14 is equal to b. wonder if that worked. No, it's negative. No, wait, what am I doing? There we go. Yeah, there we go. 14 is the b. Was that a negative slope? Sure enough, negative 3 over 2. Yeah, that works. Yeah, it does work. So let's see, a quick summary. Parallel lines have the same slope. Perpendicular lines have slopes which are negative reciprocals of each other. So you take the slope, flip it, change the sign. And thank you for watching this short lesson.